From the George Ignatieff Theatre at the University of Toronto, the Canadian Broadcasting Corporation presents the 1989 Massey Lectures by Dr. Ursula Franklin. Her talks are being broadcast each night this week on Ideas and are called The Real World of Technology. This year, for the first time, these radio lectures are being given in public through the generous cooperation of the University of Toronto's Massey College, whose master, Anne Sadelmeyer, will introduce Dr. Franklin.
The Massey Lectures were first commissioned by the CBC in 1961. Named in honor of the late Governor-General of Canada, the Right Honourable Vincent Massey, the lecture series was created to present Canadian radio listeners with the results of original research in important areas of contemporary thought. Through publication, they then take on an independent life of their own. The first lecturer in 1961 was Lady Barbara Ward Jackson. Her lectures, The Rich Nations and the Poor Nations, became a central work in the literature of international development. Since then, the lectures have been given by a long list of distinguished Canadian and international speakers. Some of them are now considered classics in their discipline. One thinks of Northrop Frye's The Educated Imagination, C.B. Macpherson's The Real World of Democracy. Tonight's listeners will recognize the implied comparison in this year's title. John Kenneth Galbraith's The Underdeveloped Country, George Grant's Time as History, Martin Luther King's Conscience for Change, R.D. Laing's The Politics of the Family, and many, many more. In more recent years, the list of Massey lecturers has included Carlos Fuentes, Doris Lessing, Gregory Baum, and last year, Noam Chomsky. Our lecturer this evening is Dr. Ursula Franklin, an experimental physicist and emeritus professor of metallurgy at the University of Toronto, where she is the only woman to have been given the title university professor. The breadth of her academic interests, which range from the structure and properties of metals and alloys to the use of modern techniques in archaeology, has led her into many areas. 2 years ago, for example, when she stopped teaching in the Department of Metallurgy and Materials Science, she was appointed Director of Museum Studies. Last year, she helped organize the International Archaeometry Symposium at the university. She is an affiliate of the Institute for History and Philosophy of Science and Technology and of the Royal Ontario Museum, and a former board member of the National Research Council and the Science Council of Canada. True to her Quaker experience, she is active in community affairs, the voice of women, and many public activities concerning peace, international understanding, and the role of women in society. The recipient of many honors, a Fellow of the Royal Society, an Officer of the Order of Canada, that dedication to knowledge for the benefit of humanity is perhaps best exemplified by the inscriptions on 2 of the many awards on the walls of her Massey College office. The Marguerite and Vernon Heaslip Award for Environmental Stewardship, given by the National Survival Institute, the Canadian branch of the United Nations organization, and the Wiegand Award for Canadian Excellence, for making significant contributions to society's understanding of the human dimensions of science and technology. Professor Franklin is no stranger to the CBC and to the Ideas program. It's a pleasure and a privilege to introduce her also as a valued member of the Massey College community. Tonight, she will offer the first of 6 lectures on the real world of technology.
Thank you, Anne. As I see it, technology has built the house in which we all live. There's hardly today any human activity that does not take place within this house And compared to people in earlier times, we rarely have a chance to live outside this house. And in these lectures, I would like to take you through the house, starting with the foundation and examining with you the walls that have been put up or taken down, the stories and turrets that have been added, the flow of people through this house, who can come in, who can go into particular spaces. I want to know as much as possible about that house that technology built, about its secret passages, and about its trapdoors. And I also would like to look at technology in the way C.B. Macpherson looked at democracy, in terms of the real world. Technology, like democracy, includes ideas and practices. It includes myths and various models of reality. And like democracy, technology changes the social and individual relationships between us, and it has forced us to look and redefine our notions of power and of responsibility. Tonight, I would like to talk about technology as practice, about the organization of work and of people, and I would like to look at some models that underlie our thinking and our discussions about technology. Before going any further, I would like at this point to say what technology for me in this context is not. Technology is not the sum of the artifacts of wheels and gears, of rails and electronic transmitters. For me, technology is a system. It entails far more than the individual material components. Technology involves organization, procedure, symbols, new words, equations, and most of all, it involves the mindset. In subsequent lectures, I will focus on technology as it has changed our realities of time and space. I will talk about planning and forecasting, and about the many attempts to predict the impact of technology. Technology also needs to be examined as an agent of power and control. And I will show you how much modern technology grew through the prepared soil of the structures of traditional institutions such as the church and the military. Like democracy, technology is a multifaceted entity. It includes activities as well as a body of knowledge, structures as well as the act of structuring. Our language itself is quite poorly suited to describe the complexity of technological interactions. How does one speak about something that is both fish and water, means as well as ends? That's why I think it is better to examine limited settings where one could technology in context, because context is what matters most. To begin with, as I said, I would like to look at technology as practice. Kenneth Boulding, the author of The Image and many other influential books in the social sciences, suggested that one might think of technology as ways of doing something. And he pointed out that there is a technology for prayer as well as for plowing, for controlling fear as well as for controlling flood. Looking at technology as practice, as formalized practice, has some quite interesting consequences. Around here, that's how we do things, a group will say. And that's their way of self-identification, because others, quote unquote, do the same thing differently. A different way of doing something, a different tool for the same task, separates the outsider from the insider. I once was invited to examine Chinese bronzes at the Freer Gallery of Art. The purpose of the gathering was to exchange experience, make suggestions for research, to share knowledge, and to avoid duplication. We were about 6 or 8, and I will never forget the scene. My colleagues were art historians or museums people. I was the only person coming out of engineering. We were all looking at bronze fragments, and we all had magnifying glasses. But my magnifying glass was different from the magnifying glass that everybody else had. They, quote unquote, had magnifying glasses which they put to their eyes, and they lifted the object into a proper viewing distance. I had a magnifying glass that I put on the object, and I juggled my head into a good viewing position. They took one look at my magnifying glass, and I was out. I was classified as an outsider. I was treated politely. A lot of good relationships came out of that meeting. Still, I feel to this day that feeling of distance, the looks, and I knew I was respected, but I just wasn't one of them. There is in that common practice that a particular technology represents also the development that leads to the right of the practitioners to exclusive practice of the technology. And this is how the professions were born. When doctors, lawyers, engineers, or social workers all claim the exclusive right to certain tools and to certain technologies. But on the other side of that coin of technology as practice is the fact that the practice defines the content. I've spoken earlier of Kenneth Boulding's remark that there is a technology of prayer. And the sacred books of most religions lay out the practices of prayer quite precisely. And that laying down of the practice means that other forms of worshipful activities, however deeply they may be felt, cannot be considered as prayer. For instance, the playing or listening to a particular piece of music may very well be felt as a deep plea for deliverance. It isn't prayer. And I think it is important to see to what extent the technology can define the content. But back to technology as practice. I want to say that there are two useful ways in which to distinguish the development in which technology has proceeded. There has been a great deal of work-related technology. Work-related technologies make the actual practice easier. That's quite simple. The substitution of electrical typewriters for mechanical ones is indeed a work-related technological improvement. But then there's also control-related technology. Those developments that do not primarily address the process of work and aim at making it easier, but try to increase control over the operation. Think of a word processor. A freestanding word processor is indeed a work-related technology. It makes work for people who type, like me, who type poorly, very much easier. But link those into a workstation and into a system, and that technology becomes control-related, because the workers can be timed, assignments can be broken up, and the interaction between the operators can be monitored. Most of the modern technological changes involve control and control-related operations, very much more than work-related ones. Now, why it is not difficult to understand the difference between control-related and work-related technologies, I would now like to introduce a concept that may be somewhat more difficult to grasp. I want to distinguish between two very different forms of technological development. The distinction that I need to make is between holistic technologies and prescriptive technologies. Again, we are considering technology as practice, but now we are looking what is actually going on. What happens on the level of work? And these two categories of holistic and prescriptive technologies have very different specializations and divisions of labor, and consequently they have very different social and political implications. Again, let me say, what interests me is not what is being done, but how it is being done. Holistic technologies are normally associated with the notion of craft. Artisans, be they potters, weavers, metalsmiths, control the process of their own work from beginning to finish. And their hands and minds make situational decisions as the work proceeds, be it on the wall thickness of a pot, on the shape of a knife edge, decisions that they only can make while they are working. And they draw on their own experience, each time applying it to a unique situation. The products of their work are one of a kind. However similar the pots may look to a casual observer, each piece was made as if it were unique. I want to quote a short paragraph from Melville Herskovits. It's from his Economic Anthropology, which was published in 1952. He points out, as an anthropologist, how often very sophisticated level of specializations exist in various societies. And he writes, in still other societies, certain men and women specialize not only in one technique, but also in a certain type of product. As for instance, when one woman will devote her time to the production of pots for everyday use, while another one will make pottery exclusively for religious rites. It must be stressed that except under unusual circumstances, we do not find the kind of organization where one woman specializes in the gathering of clay, another in the fashioning of it, a third in the firing of the pot, or where one man devotes himself to the getting of wood, another to blocking it out roughly, and the third one to carving it. It is this specialization by product that I call holistic technology. And it is important because it leaves the doer in total control of the process. It is quite different from the specialization by process, which I call prescriptive technology, based on a quite different division of labor. Here, the making or doing of something is broken down in clearly identifiable steps, and each step is carried out by a separate worker or groups of workers who need only to be familiar with the skills of performing that one step. And this is what is normally meant by division of labor. The notion of division of labor is most familiar to us from the Industrial Revolution, where the factory system resulted from large-scale applications of such divisions of labor. However, that form of division of labor, that form of breaking something up in separate processes, separate steps, and giving each person just one little step to do, is much older. The ancient Romans made much of their pottery, particularly the ware that is called terra sigillata, in a mass production mode, essentially by such prescriptive technologies. We have the texts. We, of course, also have the artifacts. But more than 1,000 years before the Romans did that mass production, the ancient Chinese made bronze vessels, and they organized the prescriptive technology par excellence with that clearly defined division of labor. The Chinese way of casting bronze, which began well before 1200 BC, is indeed a production method, and it is also unique to China. I'd like to take a moment to describe Chinese bronze casting techniques to you, not only because I love Chinese bronzes, and I've spent a lot of my professional life studying them, but also because Chinese bronze casting is such a magnificent example of prescriptive technologies and their social impact. I think that understanding the real meaning, and that means the social and political meaning, of the division of labor and prescriptive technology is the most important step to understanding the real world of technology. Now let's quickly imagine that it's 1200 BC, the height of the Shang Empire. A large bronze vessel has to be cast, one of these big things that you see in the Royal Ontario Museum, a cauldron, the Chinese call it a ding. And how would that happen? Assume you would be the emperor. You would say, hooray, we beat them. Let's have a big ding for the occasion. First, there would be a model made. The model would be life-size, full-scale, with all the decorations on it. It would be made in clay, but it also could be carved in wood. And if you were the great I Am, you could say, I like that one, but I don't like this one, because you would be sure the final thing would look like that. Once you approved the model, a mold would be made. People would put very fine clay first and then coarser clay around that model and then would let it dry. That mold would be carefully sliced and taken off, almost the way we peel an orange. Imagine you peel an orange really nicely in segments and carefully take the segments off. This is how the dry mold is separated from the model. The mold is then fired. It has to be fired to a temperature that is higher than the temperature of the molten copper or bronze that it will contain, because you don't want to make that thing and then the thing collapses on you. The mold must hold the hot metal. Once that is done, the mold, now fired, is reassembled around the core. Now imagine your orange peel and a round sphere of glass. You assemble that orange peel nicely around that sphere, but you put little stickers in so that there's a space between the mold and the core, because there ought to be some molten metal poured into that space. And you will need the various funnels and vents to not only pour the metal in, but let the air out that is in the space. Otherwise, your bronze will look like Swiss cheese. Once that all is assembled, the mold and the core is put into a casting pit. Now, up to that point, all the work required two particular skills. There was the skill of the model maker, which was the greatest skill, because not only did they have to make the model, they also had to understand the whole process, because the model had to be right. Otherwise, in the end, the thing wouldn't come out. Then there came the pottery workers, who really didn't have to know anything but how to make a clay replica, take it off carefully, and fire it properly. But now the scene shifts. Now you need the metal workers, the people who can prepare the alloy, melt it, and pour it. Now that's not a trivial task, but it's one of a completely different discipline. The thing that you might call these cauldrons were big. Even in 1200 BC, these were 850 kilograms. That's about just under a ton. And you imagine yourself being in charge of a workshop where people have to handle, even if it is broken up into small containers, a ton or so of molten bronze. And bronze melts around 1100 centigrade. And you think of the labor force, you think of the tools, you think of the discipline. When you are the guy who has to say now, because it has to be cast in one pour. We know from X-rays of these that they in fact were done not just little by little from small crucibles, but they were done in one pour. And it was indeed in considerations of the details of that situation, what would you do as an engineer if you had to cast one of these vessels, and it was 1200 BC in China, that it came to me what prescriptive technologies mean. What they mean, not in terms of making bronze, but in terms of discipline, of planning, of organization, of the institution of control and command, because you not only need craftsmen, you need a boss. And you need people who obey the boss. And there isn't time for anybody to say at the crucial moment when you want to say now, sorry, sir, I have to go to the washroom. It is a situation in which one realizes that what these prescriptive technologies are, beyond methods for production of large-scale vessels or implements, is that they are social innovations. They are one of the most important social innovations because they are designs for compliance. They are designs for discipline and compliance, for order and obedience. And I think that is really the most important thing. These technologies need to be prescribed sufficiently clearly that each step is carried out correctly so that it fits into the next step. And when a workforce works in an atmosphere of such prescriptive technologies, they become acculturated to them. They enter into a milieu and into a culture in which external control and internal compliance is considered normal and necessary. And eventually, everybody thinks there's only one way of doing this. It is a seedbed for orthodoxy. And I'm sure that the ancient Chinese could not imagine bronze being made in any way differently, just as we can't imagine that cars are made in any way differently from how cars are made all around the globe. So I think, and I have always held, that since the bronze casting is not the only prescriptive technology in China, we find it in certain textiles, we find it in the pottery, that these technologies have had an enormous formative influence on Chinese philosophy, political thought, and government. And the early development of Chinese bureaucracy, and particularly also the imperial examination, the stress on what the Chinese call li, the right way of doing something, comes out of that acculturation of a population through prescriptive technologies. And this is why I consider the distinction between holistic and prescriptive technologies so important, because prescriptive technologies, of course, have gone well beyond the production of material things. They have moved to administrative and economic and very much government activities. And you just for a minute think of filling out an income tax form. That's an exercise in prescriptive technology that everyone in this country goes through at least once. And we think at the end, or tend to think, that this is normal, that everybody has to do it. And there you go, one step depends on the other, has been prescribed, has to be fulfilled, and you try and use some imagination and incentive and situational judgment. And you know that prescriptive technologies are designed for compliance. They are important social inventions. And on them rests the real world of technology in which we live. And so I think while we should not forget in any way that these prescriptive technologies were exceedingly effective and are exceedingly effective and efficient, they come with an enormous social mortgage. And that mortgage is that we live in a culture of compliance, that we are on and on through these conditioned to accept orthodoxy as normal, that there's only one way of doing it. As time went on, more and more of the holistic technologies were supplemented by prescriptive technologies. Prescriptive technologies after the Industrial Revolution, after machines began to be added to the workforce, prescriptive technologies spread like an oil slick. And today the temptation to design more or less everything according to prescriptive and broken up technologies is so strong that it is even applied to those things that in this society, as in all others, need to be done in a holistic way. Let me just, for one quick digression, let you think about the degree of ordering and directing that exists in our society. Think for a second about these smart buildings, where somebody has a card with a barcode, and according to what is on their card, they can go into certain areas they cannot go. But they can also be programmed so that somebody can keep track of what the movements of any one person are. Now just think for a moment, Adam and Eve had lived not in a garden, but in a smart building. And I'm sure the divine designer would have arranged things so that they would have never seen an apple. But I think, joking aside, the prescriptive technologies eliminate choice and eliminate principled choice. And I think it's very important that we realize that in these innocuous things, such as smart buildings or so, sits a technology that is a social design for compliance, and is also a design that eliminates any situation in which you or I can make a principled decision. And this is design, and this is the real world of technology. There are a number of concepts that will run through these lectures. One of them is based on the experience of growing things. And there's a model that is based on the later experience of producing things. And there's a real difference between a growth model and a production model. It's important that we talk about this because it's only these common models and the common metaphor is what it makes it possible for us to talk about things. And often the models are not stated. They are underlying the discourse. The normal old model that one used as figures of speech was a model of the cycle of growth. It seems that the folklore is a bit skeptical of the overgrown. It's always the giants who are stupid and the little people are smart and agile and get through. It is in production that growth and scale suddenly become dimensions that can be manipulated, because what is very characteristic of a growth model is that one can promote growth, but one cannot commandeer it. Essential to the experience of growing things is that the human intervention in growth is such as to study, observe, cherish conditions of growth, to try to provide an environment of growth. But growth cannot be commandeered. On the other hand, when we look at a production model, production can be arranged in a way in which growth cannot. In the production model, one begins now to think that all essential parameters can be externally controlled. There's input and output, And even if it doesn't work this time or for you, in principle, more knowledge, more fiddling with the system can produce the desired output. No such thing if you think about what you're doing in terms of growth. There's always, in terms of growth, that element of being well prepared, and then there's something that is left to chance and grace. Now, what is important for us in the production model, in contrast to the growth model, is that the growth model very much emphasizes context. You grow things in a particular soil, under a particular condition. Context is essential. On the other hand, production tries to be independent of context. One brings in those variables that can be controlled, and whatever is outside that narrow production setup is external, is externalities, are things that are in fact designed and economically considered as irrelevant. Think of a work situation, a production line. There are important factors, such as the physical and mental health of the workers. But in the production model, these are considered other people's problems. They are externalities. And we know today that this discounting of context and the failure to consider the external and boundary effects are in fact a ticket to trouble. We know that the deterioration of the world's environment comes precisely because of these reasons. Processes that are cheap in the marketplace are often wasteful and harmful in the larger context. And production models make it quite easy to consider contextual factors as irrelevant. Today, production models are almost the only guides for public and private activities. And again, you see it in education. If there's anything that's growth, it is learning. And still we look at education as if it were a production model. Universities send out to parents and students brochures that point out that different universities produce different products, seemingly saying that if a student goes to one particular university rather than to another, they would be identifiable, specifiable products. And of course, what we ought to realize is indeed the fact that one deals with growth, and it's to the detriment of all to forget it. Same goes to healthcare and many other things. But I want, at the last, in that contradiction of growth and production, mention one aspect that is very rarely discussed. And that is an aspect that again came in the Industrial Revolution, and it relates to population growth. You remember that before the Industrial Revolution already, there was a fascination with numbers and population increase. It was a time where people, not only like Malthus, but Ricardo, Adam Smith, were preoccupied to a large extent with the growth in numbers of the lower classes. Now, funnily enough, there was no such preoccupation with the growth in numbers of the rich. I looked it up, and Queen Victoria had 9 children. The youngest was 3 when the Prince Consort died. She had 39 grandchildren, and neither any one of her children or any one of her grandchildren died in infancy, which was common at the time. And the drain on the public purse, one would think, of 39 grandchildren of Queen Victoria was substantially larger than of 39 grandchildren of wives of miners or farmers. Nevertheless, the tutting was the growth in number of the poor. Now, out of this came a part of science, which we call demography, and one can now forecast population increases, decreases, life cycles all around the world. What is so astounding is that we have no demography for machines, while for 300 years this has gone on with people. Nothing is on the books on the demography of machines. Demography of people is a legitimate study, but who knows anything about the increasing car population? The automobile has been with society for 100 years. We have the infrastructures for their support, from the gasoline, from the service stations, roads, bridges, parking garages. There's a whole infrastructure for a machine population, but we have no demography. The numbers could be generated, but there's no political will. And in spite of what we know today about resource limitations, about smog, about clogged roads, about toxic emissions, there's no public discussion about birth control on cars. In terms of machine demography, useful statistics which could be generated are very hard to come by. And one has to ask oneself, in what society does one live when China can introduce and enforce a one-child per family policy, a policy that the rest of the world approves of, and China justifies because of the future of the country and the future of the world. But nowhere in North America, in Europe, in Japan, is there any serious discussion about a one car per family policy rigorously enforced. And I think if we want to continue to live in a real world of technology, we better look at the gaps in our knowledge that come through the approaches we take to both growth and production. I began these lectures by looking at technology as practice. And I was particularly anxious to put before you the importance of prescriptive technologies. I drew attention to the models of growth and the models that are currently popular, models of production. I did so because I think it's there that some of the changes, first in the discourse and then in the politics, have to take place. And I want to close by giving you another little bit of Ken Boulding, and it relates to these models and the need to reform, replace, and question them. And he says, we cannot walk before we toddle, but we may toddle far too long if we embrace a lovely model that is consistent, clear, and raw. Thank you.
We welcome questions, comments from the audience, and please remember to use the microphones in the auditorium.
I have a question for you, Professor Franklin. I'm a student from China, Beijing, China, and I've been studying in Toronto for 3 years. And since the 1980s, the Chinese government carried out open door policy. One part is the government says we have to firmly open our door to learn and adapt new technology from the rest of the world. And at the same time, we have to be very firmly to resist, to condemn the Western social values, the ideologies, and the lifestyle. So my question is, what is the relationship between, say, the Western technological achievements and its cultural and social values?
I would think it is so intimate, and I have discussed that quite a lot with my friends and colleagues in China. I think the link between the technologies we practice and the values is extraordinarily intimate. And I think one cannot bring in technology as a package. I used to have a lot of hope for the Chinese being able to look at technology and say yes and no to particular approaches. I think that is a task that would require a great deal more time than the present Chinese leadership has felt it had. And I think the horrible difficulties in China are largely due to that pressure of doing something that is structurally, I would hold, and others may disagree, is structurally impossible to do. That is, by my lights, the technology has to fit the values, not the values to the technology. And so I will come out of these lectures saying if we want to have a different technology, which is perfectly possible, we have to have the practice, not have on paper or in conference, different values. There are concepts of justice that I may have time to talk on. But to answer to your question, the first short question is no. One cannot take Western technology, in my opinion, and not transfer Western values. The broader path is yes. I believe firmly one can have different technologies, but one must be clear that first come the values, by my lights, and then the practice of how to impose them. It's an important question, and it's a frightfully important one for China. And I think it will be upon people like you to struggle, and it's a terrible struggle, to something that is new and different. And all I can offer you is all our help, and that we talk and struggle with everyone about it.
Tonight on Ideas, you've heard the first of the 1989 Massey Lectures by Ursula Franklin. This series, called The Real World of Technology, continues tomorrow. The lectures will be repeated at the end of March on Ideas, and at that time an expanded version will be available as a book, published by the CBC in conjunction with the University of Toronto Press. Tonight's broadcast was produced by Max Allen, with Bernie Lucht, Lon Tulk, and Gail Brownell. I'm Mr. Sinclair.
That's true, yeah. No, I went there with a hat.